today. And to start off day two, we are very honored to have Lisa Guess, who's Senior Vice President of Global Sales Engineering at Cradlepoint. And so prior to joining Cradlepoint, Lisa was Vice President of Systems Engineering at Juniper Networks. And right now she has been a member of the FCC Technical Advisory Committee since 2015. And very importantly for this workshop, she is the co-chair of the FCC's Artificial Intelligence Working Group. So Lisa, thank you. I know you're traveling and there is a considerable time difference, so we're very appreciative of your time. So without further ado, Lisa, it's your podium.
Great. Thank you so much. Let me see if I can figure out sharing my slides and get this started. Okay. Can everybody see the slides just fine? And it's in slideshow mode?
Yes, we can see them.
Okay, great. Thank you so much for inviting me. It's so great to virtually meet all of you. Yes, I am in Sydney today, and I've been out here in Singapore and Australia for a week, and it's right now 11 p.m. So hopefully I can maintain focus and stay awake. We've got some jet lag going on too, but really honored to be able to do this, and thank you for letting it be virtual. So today thank you for the nice introduction. Today I'm going to be wearing my FCC AI working group hat. I thought that was most appropriate for this. And what we're going to talk about today is really I'm focusing on what the work that we've been doing in AI and some of the recommendations we've made to the FCC. So today's talk is really a summary of that work. It's a subset of some of the presentations that we've been giving to the FCC along with recommendations. If you're in for some light reading, we did produce a white paper. It was published actually January 2021. And I've got the link there. And Kaushik, I sent the presentation over to you. Feel free to share that with everyone as well. But I would suggest you give that white paper a look. It's got a lot of information in there. It's longer than your average white paper. I think the summary is 29 pages and the whole thing is about 138 pages. But it's a lot of appendices. It's good reference material. It's not really meant to read like a novel. But you can look at that link or simply search on the FCC TAC AIWG white paper. But what we want to talk about today is some of the charter and the approach of this AI working group. We are still in our next session of 2022. So we're still studying AI and making recommendations to the FCC. And every year as we study it, we get more and more focused. We're going to talk about the charter and approach, some trends and patterns, talk about data, sources, tools, and technologies, a lot of observations that we made just from the industry speakers we had. One of the things we do is we have at least half of our sessions, if not more, we have very esteemed speakers from across all disciplines of AI and telecommunications. So we've reflected a lot of that in our learnings in not only the white paper, but in this presentation we'll go through today. So we'll talk about some recommendations that we made around data and also a use case for data that we found that would be helpful. Whoop, I'm trying to move forward there. Hold on. There we go. So this is actually the front page of the white paper. And as I said in my summary of my talk, a lot of people think of AI as something kind of science fiction, acting like human thought, they think Terminator. But what we did in this AI working group is we did start studying this topic probably in 2017. And we started fairly large. So we took a broad view of it. We went down several paths and really converged very tightly on AI machine learning as it can help the telecommunications world. It's such a large topic. It's easy you can easily be distracted and go too shallow and too broad. So we tried to really hone in on telecommunications, and we're honing in even tighter this year. as we're doing our research. So what was our charter? And this is really just to set context for the overall charter of what this working group did. And this was our assignment that the FCC gave us as a working group. So objective 1 is how can we have results from recent programs in AI, such as DARPA, the DARPA Collaboration Challenge, or the NSF Intel Joint Solicitation, the ML wins. How do we leverage that in real world systems and applications? So that was one objective. The one we're really going to dive into today is AI relies on curated and labeled data sets being available. So what do we need to know about that? What parameters, what needs to be known? And I'll touch a little bit today on objective 3 as well, of how do we use AI to extract meaningful information that might be already available. And we had several speakers come in and talk about that. That was very educational. And then the final, I'll summarize that bullet as safe use of AI. So as we start proliferating AI, what do we need to worry about with AI as it relates to the telecommunications network? Not AI generally speaking, that's a very broad topic, but what can we do to mitigate harms that might occur, that might damage the network, that might create discrimination in the network, that might create outcomes we don't want. So what we came out with is, and I'm going to focus on this highlighted text, in structuring our efforts, we very quickly found, as I'm sure all of you in the room have found too, or would agree with, one of the biggest pieces of AI and its usefulness is the data set and how it plays a central role in extracting the value from what we're trying to do. And it also consumes the largest fraction of resources in the projects. I've got a few slides on that later. The availability of data is really a challenge. What we found was people would come together and gather data. It wouldn't be curated, it would be siloed, it wouldn't relate to any other data sets, and then it would all be outdated. And then that same effort had to go on over and over again. And so that's what some of our recommendations center around. Moving on to the next slide. I thought this was kind of a fun slide to throw in here. So what some of the press is saying about data, the data sets, it's the fuel of the future. The world's valuable resource isn't oil, but it's data. And I liked this final quote. I'm sure you guys are all reading it as I'm talking over. I'm not going to read it to you, but this final quote is, I think this is true. Data becomes more useful the more it is used. So it's not really like a new oil or new energy. It becomes more useful the more you can share it, use it, curate it, and be able to leverage it in multiple projects. So if we look at trends and patterns, some things that we wanted the FCC to look out for, and I think in general the industry should watch for. So as we're going through this digital transformation, you're going to have new business models, new technologies, and there's an area, of course, the customer is always in the mix. And then you'll have your existing things where you're changing culture and optimizing your processes. So, some key projects, certainly Internet of Things is changing the world. There's a concept of digital twins. I don't know if how many of you are kind of following that topic, but it's where you find literally a digital twin and you can leverage all of your experience in one and leverage that over into the other. So it's another way of reusing data. And widespread use along a variety of fronts, data sets around diagnostics, maintenance, repair. So many areas in the telecommunications area that can be helped and boosted by AI ML. Another thing that we came to feel is very important as you think about data sets, where is data created, where is it processed, is the network hierarchy and the network architecture is going to be changing. It's already starting to change. And what I mean by that is, historically, the capital N network, if you think about our national networks and large carrier networks, they've been all about connectivity. But what we are finding, and many speakers covered this topic as well in agreement, is that you're going to start to see an intertwining of communications, compute, and storage technologies throughout the network. So if you look here at the bottom of the slide and you'll see a lot of real-time data that happens right there at the device, at the IoT device. And so you're doing some processing there, you're doing some storage there, you're maybe sending exceptions to the cloud, and you're collecting a whole lot of data, but it's probably very tactical. And then as you move up the tiers of your network, then you'll see the device edge, the compute edge, and then finally the cloud. We feel that's where deep learning takes place, decision making in the mid tiers, and then again real time at the devices. So a good example is one of the examples they brought was it's a transportation service where it's a car that can hold 6 people, and they needed to have a battery monitor for this car because it was a lot of data, and they were sending that up to the cloud, and it was just pinging the battery saying, is the battery okay? Is it okay? Is it okay? It was an electric car. And so by having a slice of compute, this customer was able to then only send exceptions to the cloud, save on their bandwidth, and do some local compute at the site. So what else are some factoids about data? I found this to be very interesting, is 90% of data stored digitally was created in the last 2 years. So if you think about the trending of that, where is this going to go? I have a slide in a minute that's going to show, we used to have 15 billion devices connected. In a few years, we'll have 75 billion devices connected. So the data is going to grow and grow exponentially. Between 2 and 4% of the data was actually used. So lots of data, but less than 0.1% was analyzed. And I found this astounding. Between 25 million and 50 million people around the world were involved in collecting and curating data. So this is a phenomenal task that needs a lot of attention on how to manage this and curate it properly. And the experts we heard from stressed the art of picking the right data and the right model. And that really plays a big role in how you're going to solve the problem. We saw that especially in the DARPA Spectrum Challenge, where the different teams were competing in the challenge, and the model and picking the right data sets really was probably the biggest factor in who won the competition. And if you look over on the right and you look at the solution cycle, you'll see, again, supporting this, data acquisition, transformation, that's nearly 80% of all the resource and effort put into the whole solution cycle. And there's other data I didn't include in here, but if you'll look at the actual processing of AI is probably 10% or more of, not much of the resource in the solution cycle. It's really the acquisition, transformation of data, and the curation of the data. And I touched on this earlier, that, a central issue, probably the central issue, is that the data is siloed. It's collected at a point in time, and then it never gets reused. We had speaker after speaker talk about how they came together, got all the data, spent a lot of money on it, and then it just kind of stayed on on storage somewhere and wasn't able to be reused because it wasn't cataloged, it wasn't kept up to date, it wasn't in a consistent manner with other data sets. So this really played into a recommendation we made to the FCC. And kind of to wrap up the whole point, data becomes more valuable the more it's used. The more it's extrapolated from, the more it's leveraged, the more valuable it becomes. So, and if you look out in the, if you look in the world of the customer, or the market, I'll say the marketplace. So I talked about these connected devices. Not only are we having this exponential growth in device connectivity, which creates even more data growth, it's it's going from being dominated by consumers, and it's already crossed the threshold, and is starting to be led by industry. It's the IoT sensors, it's, you know, the variety of applications that are out in there in the customer base. And what this does, it not only is more devices, but it's also the devices being used differently. Consumer devices are just that, they're being used by consumers, but when industry gets involved, they're running things of value, things that may be critical, things that produce profit for companies, that solve a lot of human needs. So it becomes more critical to be able to manage all of this data. And this is just a supporting graph for that. So what we have found is we'll have continued growth in the consumer space, but very rapid growth in the enterprise space, in all things IoT, smart everything, everything connected. And again, more ways that data relates to each other, and the more mission critical it's starting to become. What are some of the types of data that we saw? So sensors, platforms, data source types. This is by no means a comprehensive list, but these things on the list are items that, well, I'll kind of give away my hand of what I'm leading up to toward the end, but something we find that will be very valuable is developing a national broadband map. And all of these kinds of data, plus more, will need to be used to develop an accurate map. You might need to use this data for your network planning, especially as 5G becomes more prevalent and millimeter waves are used. The planning process for the marketplace is going to be impossible unless we do have curated data, meaning like we know what type of foliage is where, what type of terrain is where it is, and processing all that. And then you put in the element of time and space, because you've got seasonal aspects, you've got distance aspects. So, just one aspect of this, if you look at the LiDAR technology that you might need to really do an accurate broadband map or an accurate wireless map for the country, you're looking at something, LiDAR can produce 1.5 million data points per second. So you've got that, and you're running in multiple locations. So again, you can see there is a big need for the data curation. So what are some topics that we dealt with and some categorization we made? So the general abstract label of data doesn't really convey the whole essence of what data can mean. So it doesn't capture the variety of, there's data types, there's completeness of it, there's specific requirements it could be associated with. How does it impact the ecosystem? It plays a central role in extracting value from AI ML applications. And making progress with it requires that the relevant data is verified, that the community trusts it, the stakeholders trust it, and the provenance of it, so that they know that it's useful data and it's able to be relied upon. And you think about, the second bullet, you can read it in the background, but what I was getting at with this is you think about the carriers, and they want to invest in closing the digital divide, and they want to know that the data is accurate, it's reliable for them to do their network planning and their business planning, so that they can make the right investments and be able to close that digital divide. And without the ability to have consistent, accurate planning and the right amount of, the proper type of data sets, and a lot of vendors may depend on this, or places in the market, not just carriers, it could be, it could be third parties, it could be a variety of constituents, but it's good for the economy and technology advancement so that we have a consistent view of what is possible. I was thinking I heard a noise, but I guess not. I didn't know if anybody had a question, but so the working group identified the availability of, and this was important because this showed up in our recommendations, the availability of relevant data sets and the uncertainty of the business models and policies surrounding it are the single most important impediment to progress, and something that does need to be solved. So what are some of the pieces of data? What do we consider as we curate? We had a subgroup that really did a lot of thinking on this topic. So you've got, technical, operational, a variety of data all the way up to legal. It has different characteristics. It may come from different sources. It may come, when I first was thinking about data, I was thinking, well, it's just the sensor and device and maybe some mapping or whatever, but there's really a comprehensive set of data that you need to consider when you are doing something like a national broadband map or like network planning, or just understanding the characteristics that you can expect out of the network. Maybe it's preventive maintenance. Maybe it's, understanding the capacities you need to have in certain sites, but all this data comes to bear. It has different ownership. That's another challenge, is how do you get the data? Some is private, some is proprietary. One of our speakers that came had really probably one of the best ideas, I thought, or best ways to look at solving how to share data and how to anonymize data, and was really looking at it, treat it like open source. So it's an open source license. It's somewhat crowdsourced and anonymized. And they had done some experimentation with it. It was one of the carriers and had some success, but this area definitely needs more resource and attention. I'm not going to go through this whole thing other than to say there's a lot of frameworks that have been created. This one happens to be the Nist data framework to develop practices for use and curation of data. The frameworks are critical to understand how to warehouse it, how to curate, manipulate, and reference it. I think this is a very good data framework. But what we also found was a framework specialized to the telecommunications sector would be in order here, and it would be very important to the network performance. So now we get to the recommendations. So we identified 5 recommendation areas. I'll briefly go through these, but the second one is the one I'm going to focus on. But I think they're all interesting. So we recommended to unlock change, as in let's incorporate AI into the FCC strategic plan. The FCC has every 5 years, I believe it's every 5 years, they redo the National Strategic Network Plan, and it's time to include AI in that. So we will recommend that again this year. Our second recommendation, which we've been talking about, which wouldn't surprise you based on, I'm leading up to this, but unleash the data and build knowledge around it. So create a task force to understand how to have data governance and curation. Now this is a very careful area, and in the white paper we had very careful wording. This does not mean the government controls the data, that we have laws over it. It's more of how do you gently facilitate the sharing of data across, your educational community, your commercial community, your carrier community. How do you have, and there are many examples of this that have happened in the past, but how do those communities share their data and create data that doesn't have a silo and that can be curated? So the task force was really about just understanding more about it, and how you might have a policy that you put in place that it's a carrot, not a stick, that does encourage the sharing of data. So I think that's very important. And again, we're going to be addressing that again in this 2022 session with some of our pilot projects we're recommending. I talked about the broadband map in number 3. I think that's a great example of where you can, that's why we need data sets to build an accurate broadband map. And we covered safe use of AI in this white paper, several pages on this, on how it could impact the nation's networks and what to watch out for. And then just we recommended some pilot projects, and they came back this year and asked us to make more and deeper recommendations on those pilot projects. So I thought that was exciting. So I'm going to dive down a little bit into the second recommendation about data governance, operations, and curation. So it's key. We felt we called it a task force, not for any reason other than it's something that comes together for maybe a year and reacts very quickly and provides a written result, and doesn't stay forever and doesn't change how the government operates or anything, but it's really a point of learning and trying to understand more and provide deeper understanding within the FCC on policies around it. And we recommend having some experts that were part of this task force, so that they could share the learning within the larger part of the FCC. Some of the things this task force would do would explore approaches that promote the sharing. This is really what I was just talking about. It's how do we promote sharing to extract value, but do it in a positive way with positive reinforcement through policy. And what role does the FCC play in providing we use pre-competitive, it's not a business competition, it's the research community. And how can we get better access to specific curated data sets that will help and and we think the research community is a key part of solving some of these problems and kind of leading the way here. And finally, encourage the formation and use of consortia to provide widely available benchmarks for data attributes and performance. So we spent a lot of our time really looking at data. How do you generate it? How do you curate? Who are the people that can really help lead the way? And it is, academia, research. I think it'll get monetized down the road, but I think you need some neutral parties that guide you toward the best solutions that are neutral, for revenue impact. So I'll just close out with this. This is that example of the national broadband map, and I'll just kind of go through this quickly. But if you look at step one, here's all the constituents. You've got service providers, commercial users, consideration for consumers, and you need to have all of this input. We had recommended putting out an RFI, and it was our hope with the RFI that a lot of different folks would answer that might have different sources of data. Think about a fleet, a delivery fleet. They may be able to gather data to help do some of the very granular mapping of the signal that's available across the country. That's just one example of it. And so the third step in this was to really analyze the RFI, get the budget and approvals, and then the system that you develop, we envision to be such as this, which is design, build, collect data. Again, it's that all important data, deploy and update, operate and refresh. And I'll just kind of bring it home here. And if you'll just focus on the center circle here, the center part of the graph, you'll see AI ML is every step of the way as you're developing this national broadband map. And it's especially relevant here in the collect data, deploy, update cycle. That's where we get into data reduction, data refinement, data consistency, and that becomes very important. And again, this was just one example out of many that we came up with, and there's infinitely more that we didn't even have time to consider. But I thought this one could be of interest to everyone here in this call, and I thought it was a great example of how a data set can really help not only move the market forward, but move the country forward. Because we all know, having an accurate map leads to solving some of the digital divide. So that's my specific example. And with that, I will kind of close out here. I think I'm just about on time. And, thank you for letting me come speak with you and share some of our findings from the AI working group and some of our open items and some of the areas that we think need to be looked at further.
Lisa, thank you very much. This is extremely informative, and we all learned so much. I'm sure there are a bunch of questions that we could have from the online audience as well as from the in-person audience. So for those of you online, if you wish to ask a question to Lisa, please do put your question in the chat, and we'll try to monitor the chat and make sure that question gets answered. So I have a leading question into this. So you mentioned the need uh, for leadership in this domain where we are able to create these representative data sets. So do you imagine the FCC playing a role where it would create or help to create that next MNIST or that next CIFAR data sets, which would become representative for the telecommunications industry and research? Or should it grow more organically from challenge competitions, academia, or industry-driven data sets? So where do you see the FCC's role in that very, very important problem of representative data sets for the community?
I see it in more the latter of what you mentioned, where it's going to come out of academia, out of crowdsourcing. There may be some other creative ways we get it. I see the FCC where their key role is, and this is where we're guiding them, is to help facilitate the sharing of the data in ways where there, like, maybe there's some incentives. Like, for example, what if you had a major network provider and they got some kind of a reward if they allowed academia to use some data that's anonymized and shared in a consistent way. So I could see the policy providing an incentive for the data to be shared. I also could see the FCC helping provide a structure or maybe a suggested structure. And that would be something that this task force might recommend. But I don't see them actually creating the data.
Got it.
This is Sneha Kumar Kasera. I'm from the University of Utah. Thanks for that great talk. I have a question, and this is about, we are talking about RF data here specifically. So it's not that hard to passively collect data, RF data. So you can tune to any frequency and start collecting data, especially with SDR-based equipment and all kinds of equipment you can use to do that very flexibly. The challenge comes when you have to transmit and receive data in different frequencies, and we are not allowed, we cannot, right, legally to transmit in different frequencies. So how do we, because a lot of that data would be so useful, how do we solve that problem?
Well, now you've asked me a tough question. I think that's a very hard problem to solve. I think what we envision more is along the lines of the passive collection. I would kind of argue that that's a big problem to solve too. It's in that you may need more granular coverage or ability to collect more granular data and to see exactly what frequencies you're able to have. And then you could have some extrapolation mathematically to help determine that. But when it comes to transmission on, spectrum is spectrum, and it's owned by people. I think actually, as I'm talking to you, I kind of think it's almost a little bit of the answer that I gave Kaushik, which is, I think if you do some discussions and get creative, maybe there are ways for policy where there's a benefit to the owners of that spectrum to allow some sharing of it.
So we totally believe in that, and that there is a benefit to the owner. It's just that how do we get the owners agree to do that, and also to do real data collection over large periods of time, And, I mean, I'm talking specifically about our powder test bed in Salt Lake City, okay, where we can, we could collect that kind of data, a lot of data, if we had, stable access to different types of spectrum, like, not just for a month, because it takes a lot of time to build the right kind of hardware to be able to transmit at the right kind of power levels to collect the data. But like over a slightly larger period of time, if we could get that kind of access, I think we can make a big change in how we look at wireless research. We just don't have that opportunity.
I think, Sneh, if I can jump in here, there is a subtle request to the FCC that you're making that allow us this and let us go ahead with this, or at least streamline the process where we can get permissions. So Lisa, I'll let you take that.
I think so. Yes, that's exactly right. And but it's subtle, and things don't move quickly. And I saw the other question. I lost my train of thought for a minute. Oh, I think I actually, so I'll just be very share my story. But we did this white paper and we recommended pilot projects, and I was really hoping we would get some picked up very quickly. And except we're studying them more. And but I think that's where we as a group are trying to gently lead by the pilot projects. And I'm actually taking a note because I really liked your question. Like maybe there's a pilot project we could guide the FCC toward that would help highlight what this issue is and provide more education, and then help that in turn become policy in a way. But as we all know, this will take time to do.
And Lisa, for that, we will be very eager to tell you more about some of the power platforms and capabilities that can become venues to start off with these pilots, and we'll be happy to engage with you and the FCC afterwards.
Okay.
Thank you. This is Yung Guan from Iowa State University, and thank you for the inspiring talks this morning. And we had great discussions yesterday about privacy issues and data sharing issues and so on. And this morning you mentioned the provenance and data creation and cleaning process. I'm just curious, and from FCC perspective, do you have any kind of general principles or guidelines to help us to decide, how we process data in a way to meet the privacy requirement, also, to be useful to the users of the data to be released? And so Iowa State, we are setting up the fourth power platform called Error. And just as Kelsey excited, so we're gonna have a session after this, and we can talk about those details and so on. But just like get your opinions or your ideas, insights about the data provenance and other issues, as mentioned. Yeah, thank you.
So we just scratched the surface of it. You saw me briefly refer to it in the presentation. We had a subgroup that looked into safe use of AI, which a part of that is privacy. And they didn't come out with any recommendations for privacy yet. We're going deeper this year with it and kind of heading that way. I think this is good input, that's something we need to make sure we cover.
Thanks.
And let's see, I see John has a question.
Yes, please, John, go ahead.
Okay, well, I put it in the chat as requested, but I'll read it out. Anyways, good morning, Lisa, and thank you for a really wonderful talk. I'm going to share this recording with some of my colleagues. So did the tech group come across any best practices for validating data sets? You're given a data set, and the person who gives it to you claims that it represents something in the real world, but before you use it for training your AI, you'd like to somehow validate both that it's, it's not just completely made up, it's actual measured data. And secondly, trying to identify some of the biases that might make the measured data not correspond to the real world distribution that it's supposed to represent. And did you come across anything in your studies that can help with those challenges?
No, what we came across was that it is a challenge. So I'll second for you that it is a challenge. And we didn't get deep enough in that particular finger of research to do a best practice on accuracy of data. We just highlighted that as an issue that we needed to look at further.
All right, thank you.
Any last questions for Lisa? It's getting late for her as well. We don't want to keep her longer.
I know I'm fading here. It's almost midnight.
Well, then I must thank you, Lisa, for your time and for really setting off very interesting discussions for day 2. We'll be in touch with you. There are many touch points, and I clearly see a great mutual benefit in working closely with the FCC on this. So thank you again.
That's great. Thank you. I welcome that. Thank you all. Bye-bye.